Hello friends, in this video we'll see how to check the drift and the drift ratio in the ETABS. Alright, so this is also an important factor that you should see in ETABS. You can check this parameter after you have analyzed your building. Alright, so let us first see some theoretical background. Right, so for that I have prepared this rough diagram over here. So you can see that this red box indicates the original position of the building, and when it is acted upon by the lateral load, so the lateral load might be the earthquake load or the wind load, so this black box represents the displaced position after the lateral load has been applied. Okay. Alright, so due to the application of the lateral load, the floors of this building are displaced by various amounts. Okay, so let me copy these values. Alright, so I'll click on copy and I'll copy them over here. So delta 4 over here represents the displacement of the roof, delta 3 of the third floor, delta 2 of the second floor, delta 1 of the first floor, and there is no displacement on the ground floor because it is attached to the footing. Okay, so this displacement of the floors is known as the drift, or you can say the Storey displacement. Right, Storey displacement is different from the Storey drift because Storey drift is actually the relative displacement of the floor. Storey displacement is the actual displacement, however Storey drift is the relative displacement, right? So let's delete them. All right, so again let's copy these values. We'll copy them, so let's place them over here. I should have moved them, right? So the Storey drift here is represented by D4, D3, D2 and D1. As you can see that the Storey drift of the roof is D4 is equal to displacement or the Storey displacement of roof minus the Storey displacement of third floor, right? So you can see that Storey drift is actually a relative term, right? And Storey drift of third floor, you can see D3 is delta 3, that is the Storey displacement of that floor minus the Storey displacement of the lower floor, right? And similarly the Storey drift for D2 is delta 2 minus delta 1, and for D1 it's delta 1 minus delta 0. Delta 0 is 0, so it's 0, right? So everything is 0. Okay, this is the difference between the displacement or the drift and the Storey drift. And there is yet another term that is called the drift ratio, and that is equal to Storey drift divided by the height of the floor, right? For example, if the height of this floor is like 3 meters, then you have to divide delta 4 minus delta 3 or D4 by 3, and the resultant value you will get as the drift ratio. All right, so you got three terms: Storey displacement, Storey drift and the drift ratio. Okay, so now we go to our ETABS. There are various ways by which you can see the Storey drift. Let's see the first method. So before that, just run your program. After that, go to display and click on deformed shape, and over here click on EQX in the load case. Okay, and we'll click on OK. So now you can see the displaced position of our building, right? And if you go to display and click on deformed shape and click on wire shadow, click on OK. And by doing that, you can see the original position of the building as well. So these here are represented by the grid lines, so you can see them right now. Okay, this is the original position of the building, and these blue lines represent the displaced position, right? All right, so if you click on this joint and after the right click, you will get this table over here, right? So here it says that point displacement and drift. ETABS takes drift ratio as the drift. Okay, so drift is actually the drift ratio, not the Storey drift or the displacement, so it's a drift ratio. All right, okay, so whenever you say drift, it means drift ratio. That is drift ratio, I already told you. Drift ratio is the Storey drift divided by the height of the floor. Okay. Alright, so for this joint, you can see that the translation mm or the displacement in the x direction is 8.983 and the y direction is 0.666 mm, right? 8.983 mm. So y in y and g direction is very small. It's because we are looking at the load case for earthquake in the x direction, that is EQX, right? That is why the displacement in the x direction is pretty much high, right? So a rotation you can also get, and drift or the drift ratio is 0.0083. Okay, for this joint, let's calculate the drift ratio, and you can see that this is on the roof. So what you have to do, you have to subtract the translation of this joint with this joint and divide the answer by this height, right? So let's open our calculator the virtual calculator. And now what we'll do, we'll subtract 8.983. Alright, so let's do with this 8.983 minus. Alright, so let's do this and let's go to one step down. Okay, let's close this dialog box and let's right click on this, and we'll see that it's 6.623 6.623 divided by, so again let's go here. So at roof level it's 9.779, right? So we'll find the height, so 9.779 Z level, and at one step down at the second floor it's 6.9342, right? So we'll do that as well, 6.934, and we hit is equal to, and is 2D. So it's 0.8295, and you can see that these values are in mm, right? And this value is in meter, so we have to make the units consistent. So for that, what we'll do, we'll just multiply this by 1000 to get the value in mm as well, the lower denominator value, right? So the units were not constant in the earlier calculation. So we hit is equal to, again S2D. Now you can see, so you shift and click on inch, shift, inch. You can see that the drift ratio is 0.30 and 8. So you can also check it from here as well, right? So if you just click on it and right click, so it's 0.000830, right? Or 830 and 829, so that has been rounded up. Okay, so this is how you calculate the drift and the drift ratio, and this value should be within the limit that is allowed by the code. Okay, so you can see on the plan that, so this is the x direction, and when the earthquake load is applied from this direction, these points are displaced to the farthest right. Okay, so we'll check the Storey drift at this point, and you can check for other points as well. For checking the drift of this point, you have to go to the elevation 4, right? So we'll click on this window, click on elevation and go to elevation 4, and we click on OK, right? So here, so this point over here is point 4C, that is this point, right? So we click on this point and right click over here. So here you can see that translation is 9.671, right? And of the lower floor, so we'll use the calculator again, and we'll place 9.671 minus. So we'll check for the lower floor as well, and for the lower floor it's 7.145, right? Minus 7.145, okay, and is equal to, I think, 2.526. okay, so we close it, and after that we will see our code. So it's IS 1893 2002, and here the Storey drift limitation has been defined, and you can check the relevant code that is followed in your country. Okay, so here it says that the Storey drift in any story due to the minimum specified design lateral force with partial load factor of 1.0 shall not exceed 0.004, that is the 0.4% times the Storey height. Okay, so you have to take the Storey height, multiply with 0.04, whatever result you get, the Storey drift must not exceed that value. Okay, so let's open this program, and here you can see that height of this point is 9.779 meter, because we are taking this point at the roof, right? So 9.779 will do in the calculator, so 2.526, you remember that. So 9.776 into 3, that is times 1000, right? Into 0.004. okay, so it's 20, right? We click on is equal to, and here you can see that Storey drift of 39.104 mm is allowed. However, we got only 2.56 mm, right? This is very much lower than that is permitted by the code. Okay, so some designers, what they do is that they just right click on it, and after that they just take this value as the Storey drift. As per the code, this value is not the Storey drift, this is only the drift. Some designers they do what is that, they just right click on it and they get the translation or the drift as 9.671, and they just multiply the height with 0.004, and after that they tally those two values. Even if that is the true method, our building is still safe because the permitted drift is 39.104 mm and our drift is only 9.671 mm, right? So it's still our building is safe and within the limits, right? Okay, so this is one method by which you can check the drift and the displacement. There is yet another method by which you can do. So for that, again go to display and click on Storey response plots. From here you can see many things, right? So for example, you can see the maximum Storey displacement or diaphragm drifts. Also you can see Storey shears or maximum Storey drifts. You can also check. So Storey displacement means the displacement or the drift of the Storey, right? So case combo will take as EQX. Okay, so we have got over here. So here the blue line represents the Storey drift in the X direction, that is marked over here. And from here also you can get the Storey drift for various values. If you hover over here, you can see the result at this position, right? So here you can get it, right? And also if you have to see in the Y direction, okay, so you can check that as well. So here the red line represents the Storey displacement in the Y direction, and you can get the results from here as well. Alright, so this much for this video, and I hope you understood it. Thank you for watching and take care.